I am a journalist with Forbes, and I am delighted to moderate conversation today between Denis Skrinioff and Iso Kant. Maybe just to start, if both of you could just introduce a little bit about yourself and your company.
Sure, I'll start. My name is Denis. I'm the CTO at Iron. We are a data center company that focuses on sustainable, large-scale data centers for next-generation workloads.
And my name is Iso Kant. I'm the co-founder and CTO at Poolside, where we build foundation models focused on reaching human-level intelligence, but specifically today oriented towards their software development capabilities.
Great. And Iso, maybe we can start with you. So Poolside has been on quite the journey. You've had huge scale in quite a short space of time. Can you tell us a little bit about what drove that scale and what the challenges and opportunities have been?
So I think the very simple answer in our space is that there's a direct relationship with the amount of intelligence you're able to train and create in a model with the amount of compute that you're applying to it. And that effectively comes through three different scaling axes. It comes through the size of the models that you're training. It comes through the existing data that you provide, essentially the fossil fuel of AI, the web, and the renewable energy version of data that you're able to create through reinforcement learning. And so all of us who are looking to be at the frontier and who are building large-scale foundation models are effectively in a race to increasingly scale up our training compute. And with that come, a host of technical challenges the moment you go to larger orders of magnitude. Today, we're at about 10,000 H200s. In our space, we need to have sight on more than an order of magnitude larger in the near future.
Wow. And just in terms of the impact that has on the team, does it, grow or become more specialized? Like how do you handle that from your own headcount perspective?
So there are kind of two ways you can go about foundation model building. You can treat it like an artisanal process where every next big model run is led by experiments that are individually led by engineers that are piecing together the components to kind of do all the experiments. Or you can treat it like a model factory, where you're effectively building the scale and automation from your raw data sources all the way to your model training to your final evaluations that happen and all the intermediate evaluations. And if you really want to scale up time from essentially the number of experiments that you run, right? We're a highly empirical field. I think it's underestimated. We often talk about the big training run that happens for X months. But really where all of the complexity comes into and the skill comes into is in your number of experiments. So I was actually, funny enough, reviewing something this morning, and I saw the number of experiments that our applied research group ran in June. And so our applied research group, at its core, is about 40 people. Poolside's 120, about 80 people between research and engineering. And they ran close to 1,800 experiments in June alone. And that is only possible when you engineer your way out of skill instead of hire your way out of skill. And so the not so hidden secret in our space is that 80% of foundation model building is just hardcore distributed systems engineering and making these things work at scale. And that comes with interesting technical things that you learn along the way and technical challenges you solve. And as you scale up compute, those challenges are often exaggerated because of both the failure rate that you get at a larger scale, but also the fact that now you are dealing with an infrastructure that you are, is increasingly more important to optimize, right? Your cost ratio and your impact is increasingly there.
And Denis, I'd love to get your perspective on what it's like to support a client with that type of growth.
Well, as supporting a small cluster client is much different than supporting a large cluster client. When you get above 1,000 GPUs, 10,000 GPUs, now you're talking about less generalists and more specialty support, right? You need liquid to chip engineers, you need mechanical engineers, you need HPC, DevOps engineers, you need InfiniBand experts, because time to resolution is everything for these customers. As Iso mentioned, it becomes more and more complex as the cluster grows. There's more and more failure rates, and having the specialties to be able to diagnose those complex problems is critical.
So speaking of complexity, let's talk a little about training your own foundational models. So you said you can't fine-tune your way to AGI. What do you think is unlocked when you control the full training stack?
That has a 2-hour answer and probably a 2-minute answer.
Give us a 1-minute answer if you can.
I'll try to give you the 1-minute answer. I think it starts with how you think about where we are today with foundation models and where we need to go. And there's a couple of things that I think we've all empirically observed already. First of all, the further you are in your training of your model, if that's fine-tuning at the very end, if that's mid-training or earlier in pre-training, the plasticity of what the model is able to learn and generalize to, right, decreases. So almost by definition, if you are looking to increase model capabilities at scale and go from the places where today they are still very flawed, like large multi-step complex reasoning, and this shows up in our domain very much so, the focus on software development. What you essentially realize is that you have to look at kind of 3 areas. On one hand, you are constantly improving the compute efficiency of your training and inference, because that effectively tells you what you can do with the resources you have. And that's a never-ending battle. Every foundation model company can look back 12 months and say we're now 2 or 3x more efficient at training, at inference. And this is kind of a constant optimization that starts from the hardware all the way to the software that you're doing, to the model architecture, your attention mechanisms, et cetera, et cetera. The second part is that you're constantly improving your data. Almost everything you do and every fancy name and technique we give in our space is about improving the data that leads to the capabilities we want to see in our model, either more data efficiently, so it does it quicker with less data, and that has this kind of next effect of you can do more with your same compute and model parameters. And then the third thing is really looking for your breakthroughs, the research that you feel very strongly about will unlock the next set of capabilities. But all of those can almost always be found into a way of providing the model with data that it hasn't seen before, that is more challenging, or making it more compute efficient to do your training.
And Dennis, talk a little bit about how you plan for infrastructure when clients and customers of yours are on that journey, especially that move from training foundational models to front-facing product.
So as a service provider, we don't really have the luxury of being able to plan for a single client, because clients usually aren't coming to you ahead of it saying, hey, in 12 months, I'm going to need a cluster that has this capabilities. They come to you last minute saying, hey, I need a cluster of X size online in 30 days. So as a service provider, you have to build for optionality and flexibility. So it's procuring 6-9 months in advance, getting the data center ready, getting the infrastructure built, getting everything orchestrated, because it's electricians, it's mechanical engineers, it's ordering all the components, it's working with the OEMs, and getting everything to work in lockstep.
So let's talk about measuring progress towards AGI. So you've raised 500 million. Specifically to pursue AGI using software development as a proxy for intelligence. So tell us a little bit about what the key milestones are that you're looking for. How do you tactically measure this?
So I think we should look at this from the inputs and the outputs. And I think the outputs are observable by all of us in the industry, right? The level of model capabilities that we increasingly get. And our benchmarks in our industry are inherently flawed. Every individual benchmark is biased, is often narrow or too task-oriented. But when you look at them as a spectrum as a whole, to try to see how models are going in both general knowledge, in reasoning capabilities, and then downstream task capabilities like software development, and then just the vibe checking all of us do, right? The using of the models, you get a good sense of, are we up and to the right, and are we improving? And so that's both, it's super important that throughout your training process, and more so the thousands of experiments that you run every month, you are measuring this progress continuously. So the way it works on our side is, before an experiment gets launched, it's determined that every X training steps, evals are automatically run. So when I spoke about those 1,800 experiments that ran in June alone, the vast majority of those will have automatic evals triggered 10 or 100 times along their experiment lifetime. Then the second part to this is the inputs. And look, 500 million is a big number, but it's not a very big number in a year from now. I think that's a really important thing to know. We are a space where you have to see reality for what reality is. And it means that the the amount of compute that you have to train your models is directly relation to the quality of models that you get on the other end out of it. And that's the input you should look at any foundation model company. How are they scaling their training compute? And that's often a little bit tricky to see because you get big highlight numbers from other foundation model labs that mix, fundraisers for inference with training. But when you're in the industry, and I'm sure for you as well, Dennis, you get a sense of, okay, the largest training cluster right now is this size in the world. The next largest training cluster will be this in 12 months. And you have to make sure that you find yourself in the ballpark to skate where the puck is going effectively.
And how do you stay in the ballpark, Dennis, from an infrastructure perspective? Like, how do you stay ahead of that curve?
It's very much, like I was saying, it's trying to watch where that hockey puck is going, planning out, working with the OEMs, working with all the big hardware providers, and seeing where the technology is headed. So it is very much the job of the service provider to plan for that, to start procurement, to start the design for the next generation of clients.
And talk a little bit, Dennis, about the risks, like especially as we see huge data center evolution. Like when customers scale fast, like what is the risk to break first, right? Is it scheduling? Is it networking? Is it space?
Well, what breaks first is assumption. The assumption that what works for 200 GPUs will work for 10,000 GPUs. Right, it's a different mentality around staffing. It's a different mentality around operating, cooling. It's managing the hotspots, managing the network, the cabling, the infrastructure. It is a completely different game once you scale to that size. The network alone is everything needs to work in unison. There's so much east-west. There's a lot. There has to be integration with the storage platform. It's a very complex beast to manage.
I thought you were going to say what breaks first is your heart, but can maybe use that the next time. So, in terms of scaling infrastructure for end-to-end AI workflows, many AI workloads now involve complex pipelines before training even starts. So, how do you support these from that infrastructure perspective?
So, from an infrastructure perspective, it's very much building and preparing the products ready for that customer. Having a storage platform that they can just get all of their data in, that has direct integrations with the GPUs, and allowing them to consume as quickly as possible, because time is money, and it is very much an arms race in this space.
So I would actually take a slightly different stab at this. For us, as we continue to scale up, we really learned the lesson of disaggregating everything away from GPU compute. So where before we would distribute data centers to our clusters, now we stream our data in, which means the bottleneck is never the input data that's getting streamed into training. So all of a sudden, that doesn't have to be the same data center anymore. That can be the nearest wired up, zone on AWS or somewhere where you are operating your data streaming infrastructure. So really treat your cluster as only doing the workloads at which it's best, which is effectively training and inference, and try to move as much of it away from the cluster itself. Now there is a good argument to be made to put storage on the same layer, and you do build out storage on that same layer because it's cost-effective way to build a large object storage within your GPU cluster. Mm-hmm. But in our experience, the more we can just treat the GPU cluster as doing what the GPU cluster is supposed to do, which is the training or inference, and moving everything else outside of it to a place where regular compute, anything that's CPU based is running, has been highly effective for us. A lot of this also has to do with as you're getting to a skill, and so much of your compute is being used for experiments. Your big training runs are relatively easy, to be very honest. At this point, they're fully automated. Their restarts are automated. Observability is automated. But it's your experiments, right? When you've got a team of 40 people running 1,800 experiments in 30 days, how do you make it really easy to deal with the allocation of resources, the resizing of things, nodes going down, and when you are no longer bounded by your data sets needing to distribute across the physical hardware of your GPUs, but you can stream this in, you all of a sudden find a lot of nice paradigms that you can just make this more efficient. And it's not to be underestimated that so much of experimentation is related to the data sets. And so materializing a data set, distributing it, can take hours or days, while streaming can usually take minutes because you can overlap the generation with the pushing towards training.
So let's take it up a notch for a second and talk about some of the more general themes right now in the broader tech industry, specifically around the demand on AI and climate change and how those two things clash. Do you guys think that you can turn sustainability into an advantage in this space?
Look, I'll probably start with the less popular opinion, and then you can give the nice popular opinion. The very unpopular opinion is the fact that if we're looking at the demands of AI, and the demands of AI are not going to come from training clusters. The demands of AI are going to come from inference. Training is a factory where CapEx goes in that builds an asset that then needs to make a return over time. And we're seeing the demand of AI massively, driving the demand for inference. And the only way that we can support the demand for intelligence on compute is if we're willing to look at a power mix that uses everything. The sun doesn't shine all day. Batteries are expensive. The wind doesn't blow every day. And don't get me wrong, I'm an incredible fan of using renewable energy to power data centers. But it is not realistic to think that that is the only energy mix that allows us to operate a data center 24/7 at peak load capacity, which is what these data centers are primarily running at when they're run well. They're on 100% at a time. And so that's when you find yourself in places like France, which is an incredible nuclear base. You find yourself places in the southern United States that has incredible gas resources. And you're realizing that you're using that energy mix. Now, you fast forward 10, 20 years, and we see batteries becoming, and battery storage becoming cheaper. We see the fact that we are likely going to end up in a world where renewables are increasingly a larger part of the mix, where nuclear is back to the scene gladly. But it is not realistic to believe that today we can do this without fossil fuels being a part of the energy mix, in our opinion.
Yeah, well, energy constraints real, right? We're already seeing it. Things are continuing to accelerate, but we need to figure out a way to do it sustainably, right? It is the influx of renewables is still coming, but it's not coming fast enough, right? As you said, SMRs are coming, but the lead time for SMRs is huge. The wind and solar projects, they take forever to complete. It is going to be, if you fast forward 20 years, there's definitely going to be a constraint that needs to be resolved.
Okay, so we have time for one more question each. So maybe first to you, Iso. So hyperscalers are dominating in the cloud, but a lot of startups are leaning towards kind of lighter, more modular infrastructure. Where do you think the winning play is?
Look, we have spent time we've worked with Iron in the past. We've been very public about our work with AWS. We've worked extensively with FluidStack. We've worked with all providers kind of along the value chain of building large AI clusters, both for training and inference. And effectively, I think if you hold the assumption that we hold, that we're only 2 to 3 years away from reaching human-level capabilities across the vast majority of knowledge work that we do behind a laptop as humans in AI, the demand projections of AI become incredibly large on an inference perspective. And they're going to require a world where everybody is building out infrastructure. That being said, I do think there is a first principles case to be made for providers who are going from the ground up and really just focused on AI. And you're one of those providers, and there's others in the market that are looking at, well, if we go from land to energy cost, to building out the cluster, to making sure that there's cheap financing to be able to finance a data center and a GPU cluster, and then really cutting away every other service and just making sure the GPUs are there interconnected and able to run, there is a very cost-competitive price picture that starts to emerge. And this is why you're seeing foundation model companies, some of them owning their own infrastructure, like an xAI is, partially where they're renting. And it's going to be a little bit like my comment on an energy mix where we have to use everything in the future, right? It's a little bit of compute mix is becoming a similar play where you'll find yourself with a mix of compute from a lot of different providers as demand increases.
Yeah, and you mentioned that hyperscalers dominate the space, but they're slow to move. There's a reason why there's well over 200 neoclouds that have popped up. There is a niche that needs to be filled, and there's a great opportunity for data center providers like us, like the others, to build from that ground up and build a cost-effective service specifically dedicated to customer requirements, customer needs.
Great. Well, thank you both very much, and thanks everyone for joining us.